Welcome back, Pre-Algebra. We're going to be in Lesson 9 today, and we're going to take a little bit of a break from math and do some geometry. So the first thing that you need to know about geometry is that a point. A point is a location in space. It has no width and it has no length. So the picture here that I've given you, this little point, this little dot, even though it has width and length, that is not the dimension of the point. It is quite simply a location, right? It has no measurement whatsoever. A curve is an endless connection of points. So think about if you were to draw a point here, and 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 a point here. That collection of points, that's a curve, and they can be in any shape whatsoever. But a straight curve is called a line. And a line does not have any width, but it has length. So a line usually has points on it. I'm going to draw a line here. And what we typically do is we put a point here and a point here, and we draw arrows to represent the fact that a line goes on forever, right? So when you put this in your notebook, your reference notebook, put line and put an illustration of a line, and note that it goes on forever in both directions. And in parentheses over here, you could say it is a straight curve. Curve is a collection of points. And a point, here's your illustration. You could just say it's a location. Think when we say decimal point or we say 4.7, we're really just saying the location or the place between the whole numbers and the fractional number or the part of a number. So the point here represents a location in space. Now, there are other types of lines. We have what's called a ray, and a ray is a line that has a definite beginning, but then goes off indefinitely in the other direction. So it has a start, no finish. All right, and then we have something called a line segment. Somebody's calling me, but I'm not going to answer it. I'm going to focus on you guys right this second. A line segment is a line that has a definite beginning and a definite ending. So it is a portion of a line between 2 points. So it is part of a line with a beginning and an end, with a, how shall I say that? Beginning with a point and ending with a point. We'll say that. Beginning with a point and ending with a point. All right, these are the definitions that you need to have in your notebook. Line, curve, point, ray, line segments. Now, there are certain ways that we write the names of these things. So, for instance, when we write a line, I'm going to put that in red above it, we would write a line with 2 little arrows, and then we would put the name of the points. Usually what we do is we give the points a capital letter. So whenever we name this line, we put the points' names right there. And when we say it, it could be line AB or line BA. It doesn't matter, whichever order you want to do it in. Typically, I do it in alphabetical order because then when you type it into the system, it's more often correct. The system will accept it. So if I do it in alphabetical order, it's better for you guys to do it in alphabetical order too because it's easier to understand which way to do it. A curve has no specific way to write it. The point is just like this, and usually we just put whatever letter is with it. A ray is written just like it is drawn. You just have one arrow, and you always start with whatever the point is that begins it. So if this was ray CD, and C was the point where it started, you would write CD just like that. Ray, and you'd write it much smaller. What I like to do is do C, D, and then just draw my little line with the arrow over the top. But it always has to have the C, or the point where it's starting, at the beginning here. That is how you have to write that. Now a line segment is written similar to this. Each point, we'll call this E and F, has a letter. But you just write a little line over the letters E and F without the arrows. And you could also write it reversed, F and E. So either one of those would be correct if you were to write this in a problem or as an answer on your paper. You could write either AB or BA. You could write line segment EF or FE. But you can only write a ray like this with the beginning point first. All right, so let's look at some example problems. All right, sorry about that. I had to answer a phone call. So let's look at example 9.1. Let me get this color here. 9.1. In this figure, let me draw the figure. I guess I better pause it. All right, so I paused to draw the figure for you. Here is the problem. We have a line, and we have 3 points, A, B, and C on the line. And we are told that line segment AB is 3 units long. So from here to here is 3 units. And then we are told that line segment AC, from A all the way to C, is 7 units. So what we need to find out is how long is BC? How long is line segment BC? So the easy thing to do, or the thing that makes the most sense, is to say, okay, which one is longer? Which one includes the other one? So line segment AC includes line segment AB. So if we take the whole thing and subtract, so let's say we would take AC and subtract AB, that should be, right? So now that we know what we're going to do, we're going to take the values of those lines, the length of those lines, and drop them into the problem. So AC is 7, so I write 7 for the AC minus AB. AB is 3, so we put 3 in here, and that should his. 7 minus 3 is 4. 4 is the length of line segment BC. So we can check that. Put this here. 4 is, it's 4 of them. We can add 3 and 4 together, and we get 7 for the whole thing. So that tells me that we did that correctly. All right? And that is how you would do a problem like that. You would figure out which one is the bigger one, subtract the portion of it that you could, that you know about, and that leaves you the part that you don't know about. So let's talk about an angle is formed by 2 rays. So remember, a ray has a point here, and it goes on and on forever in the next direction. Well, an angle is 2 rays that have the same endpoint. So this part right in here is the angle, the interior part. And This is the part where they join. That is the same point that they share is called the vertex. So there are 4 different kinds of angles. So you're going to want to write this down. Here's the first type of angle that you will have. This is what's called a right angle. A right angle measures 90 degrees inside. From this line to this line is 90 degrees. Right, and the reason it measures 90 degrees right here is because of this. If you have a square, right, we know that the interior of a square is going to be 360 degrees because it will be the same width and same height, because that's the definition of a circle. It's the same width and same height. And a square has the same property, and because of that, when we put a protractor on the corner, we get 90 degrees all the way around. And we say that these are right angles. Just 90 degrees, and you will get that right every time. An acute angle. Acute is smaller than 90 degrees. So this measurement here on the inside is going to be less than 90 degrees when you measure it with a protractor. And we'll do some protractor measurement in the next lesson that we talk about angles. We'll do some protractor measurement. Then you have, this is called an acute angle, and that is less than 90 degrees. And then the next type of angle you have is an obtuse angle. An obtuse angle is where the angle is degrees. It's bigger than the 90 degree measurement right there. So that's what we call an obtuse angle. And then there's one other type of angle, and that is when you have a straight line, point in the middle right here. This is called a straight angle. Angle measures 180 degrees. And the way we know that it measures 180 degrees is that if we were to put 2 right angles back to each other, you'd have a right angle here and a right angle here. That'd be 90 plus 90. 90 plus 90 is 180. So that is a straight angle. It's also a straight line, right? So that is the definitions, or those are the definitions of the 4 different types of angles: right angle, acute angle, obtuse angle, and a straight angle. Those are the 4 definitions that you really need to know about in angles when we really start worrying with those. So now let's talk about perimeter. I'm going to clear the page. Perimeter is the distance around. That is what that means. Literally, it means the distance around. So the distance, which we know is another word for length. So the length around something, that is the perimeter. So if I had a square right here, let's see if I can draw a square. It's not quite a square. Let me see if I can make it a square. Yeah, there we go. That's much more square-like. And let's say that with this square, each side was 4 units, which is the definition of a square. They're all the same length, right? A square has 4 sides, all the same length, and they has 4 right angles, right? That's a square. So the perimeter for this square would be all of the sides added together. So 4 plus 4 plus 4 plus 4, which would equal 16 units, whatever those units are, inches, feet, whatever. Because we know it's a square, we can easily solve perimeter by saying 4 times the length of 4, and we still get 16 units. Because it's a square, we can just multiply one side by 4 because they're all identical. All 4 sides are the same. So either way you want to do it, this is the faster way if you know your multiplication tables. So what if we have a more complicated shape? Let's try a more complicated shape. And let's see what we would have to do for that shape. So let me put one up here for us. All right, so let me put in our measurements. All right, here are the units or the lengths around the shape. And all of these are right angles. And right angles just tells us that these lines are straight up and down. So we don't have to worry about measuring a skewed length or something that's off center. It's perfectly straight up and down. So the lengths are going to line up on the top to the lengths that are on the bottom. They're going to be parallel to one another. It just makes the math easier. So the distance around this, here's what I would do if I were you. If I have a shape and it has a bunch of different length sides, I would start writing them down. I would say 8, okay, I got that one, and then I would cross it out, right? Or put a check mark by it, or circle it, or do something to let yourself know that you've already included that. Because then what if you have another distance and it's the same measurement, right? So plus 7, so I got that one. Plus 7, I got that one. Plus 10, I got that one. Plus 17, I got that one. See, I got that one out of order, so you can't count on order. Plus 15. So now all my dimensions are circled. I've got them all. Now I can add them up. And I like to add things by 2s. You could also add it this way, 8, 7, 7, 10, 17, 15, if that way is easier for you. So 3 7s would be 21, 29, plus 5 is 34, carry a 3, and 3 1s, that would be 64 units. And in this case, the unit of measure is what we call meters. So that'd be 64 meters long. And that would be the perimeter. That'd be the length. If we were to take a rope and start here and lay it around the outside of this building or box or whatever it is, it might be a parking lot, I don't know, and then measured, went from end to end, and then measured the rope, it would be 64 meters. Right? That is the length. Like, let's say this would come in handy if you're trying to put up a fence and you need to know how much fence to put up. You can measure the outside of your yard to see what the length is in order to do that. Or let's say you're wanting to put tape around the outside edge of a poster board for a project. Then you need to add up the perimeter around the outside edge of the poster board to know how much tape you need, how much tape you need to buy. So those are things that you're going to use in everyday life. Perimeter is helpful to know. So let's try another shape. I'm going to clear the page and put it up here for us. All right, so for this shape, we have, we're told to find the perimeter of this figure, and the dimensions are in feet. And the short form of feet is FT, and that's what we would use when we write our answer. I'm going to put that in parentheses for you so you have that reference. So we can add all the lengths up. So we have 6, 4, 8, 14, 8, 2. Wait a minute, we don't have a length for this side or this side. So we're going to have to do a little bit of math in order to find out what that length is. So one of the things that we can do is we can use our imagination. we can pretend that this line right here is going to go straight up, and we know it stops here and starts here at the same points, so we can envision that this line goes all the way across when we add this line segment to this part of the shape, when we just bring it straight up. And because we know these are all right angles, we know that this side of the line stops here. So this line and this line are going to be the same length. So that means that this line is 6, right? And because this line brought up here and added to these two lines is going to be the same as the bottom line, we know that it's going to be 14 minus 4 minus 2. So that is going to be 14 minus 6, which would be 8. So the length of this line is 8. All right, so you can see how using a little bit of imagination there is going to help you find the lengths of the lines. So we know this one plus this one plus this one has to equal 14 because this line is straight up and makes it stop and makes this one stop at the same location, because they share a point. All right, so that means now we have all our dimensions, we can add them together. So one of the things that I'm seeing, and something that could help you go a little bit faster, is that there are some duplicate measurements here. So first of all, I see 1, 2, 3 eighths. So I can say 3 times 8. That equals 24. And I'm also seeing 2 sixes. So 2 times 6 would equal 12. So now all that's left is a 4 and a 2 and a 14. Right? So I can add these numbers together. It's just a little bit faster. 4 and 2 is 6, plus 4 is 10, plus 2 is 12, plus 4 more, that's going to be 16. So 6, carry a 1, this will be 1, 3, 4, 5. 56 feet, and we do not put a period. That is the perimeter of this shape. Easy peasy. So this is a little extra thing that I wanted to put in here for you so that you could see this and see kind of another way to look at perimeter. All of these dimensions, you have all the dimensions that you need here in order to find this shape, this length, and this length. And I want to show you how I know that you can do this. If you were to take this side right here and bring it over, I'm going to just touch it. It is the same length as this side right here. So that tells me that this side right here is also 4. Right? So, I'm sorry, this is not 8, this is supposed to be 6. So the other thing is this side right here, if you were to bring it over to this side, it's the same height. So, oops, I made a boo-boo. Let me get this back. So this side is parallel to this side. When you have parallel lines, that means that they are straight up and down across from each other, or left and right, straight lines across from each other. They're going to be the same if you have right angles in each corner. So that tells me that this is also 6. Now when you look at the tops and bottoms of these, and this one right here, you can take the top here and bring it down, the bottom here, bring it down, and the top here and bring it down, and they are the same length, right? So those 3 dimensions combine to make the same dimension across the bottom. So it tells me that parallel lines in a rectangle or a shape that has right angles are going to have the same dimension. So that's something that you can count on whenever you are trying to calculate perimeter or area, because you know that you'll be able to line them up and get that missing dimension. So if you were to add those three up, you would have 2, 4, and 4. So this bottom missing dimension would be 10. So now you can add these all up. And again, I'm going to do it the fast way. So I see 1, 2, 3, 4 4s. That's going to equal 16. And I see 2 6s. And that's going to be 2 times 6 is equal to 12. And then I have a 10. And I have a 2. My pen just keeps making all kind of weird marks. So now I can add these up really quickly, or more quickly than I could before. So that's 10, carry a 1, and then 3 more 1s. That makes that 40. So I have 40, however many units that is, whether it's inches or feet or yards or whatever. But that is another way to look at your shape, is by dissecting the pieces to find the missing information. Another thing that you can do is, in recognizing that this length plus this length and this length equals this length, is to know that you have the top and the bottom are going to be the same. So the top and the bottom are the same dimension. They're both 10. You don't even have to add them together. So that'd be 2 times 10 equals 20. So that means that also the left and the right, they're going to be the same. So the left and the right is going to be 2 times 6. That's 12. So we've taken care of all of the top, all of the bottom, all of the left and the right. So now all we have are these 2 4s here, and that's the inside left and right, and that's 2 times 4, which is 8. When we add that up, we get 40 again. So you can add this up, or you can look at it in a variety of ways, but ultimately, if you do it like this, or if you just write each dimension down, 2, 6, 10, 6, 4, 4, 4, 4, and then add it all together, carry 3, you're still going to get 40. So do it the way that makes the most sense to you. Use some type of marking mechanism so that you don't write a dimension down more than once, and also so that you don't forget a dimension or a length of your sides. Make sure you get them all written down, you get them all counted right, and you add them together. And it's always a good idea to do the math twice. If you do the math twice and you get the same number both times, then you are probably correct. Okay? Be sure before you start adding perimeter that you have found any unknown, that's the first step. Find unknown lengths first. Then do the math by adding the lengths together. If you hear clickety clickety click in the background, that's my dog walking across the floor. He had to go visit somebody or something, I don't know. But anyway, those are the 2 steps for perimeter. Find any unknown lengths, and you do that by doing the math or the calculation to determine what that is. And then once you get all of your lengths, you add them together. And if you want to do it faster, then you can count the number that are alike and multiply them and then do the adding. Either way works. But that is all we have for lesson 9. I will see you in lesson 10.